Question 3. Sketch the graph of y equals tan of x, where x is an element of 0 to 4 pi. Again, that just means between 0 and 4 pi. Yep. Okay, let's do it. Tan's a bit of a weird one. Let's look at what points we need. We'll draw a unit circle. I'm trying to think of the best way to explain this. With tan, you want to try to memorize the shape a little bit, but that's not great advice for someone who's just learning it. So I'm trying to think how to best put it. Eventually, you will just become used to the shape. Okay. Let's think about these smaller angles. So if I'm here, remember tan, you can think of like the steepness of the line. Okay, so here it's kind of steep, but nothing crazy. Here, we're going to have a gradient of 1. Because as we go across an amount, we go up an equal amount. So our gradient is 1. Back down here, when we're at 0 degrees or 0 radians, an angle of 0, we have a flat gradient. So the gradient's going to be 0. So tan of 0 is going to be 0. Here, tan of, and this angle here is pi on 4. Tan of pi on 4 is going to be 1. And then as we keep going, we're getting steeper and steeper and steeper until we get to tan of pi on 2. And do you remember what happens at tan pi on 2? How steep are we? Tan pi on 2. I'll pause, have a think about it. How steep are we here? Are we very steep, not very steep? Are we, yeah, have a think. And then unpause and have a look. It's technically undefined. In this case, it can help to think about how it's infinite. And so we'll talk about both of those in a second. Basically, just before we hit that undefined, we're very, very steep. As we go across only a little bit, we go up a lot, which means it's very steep. Now, as we keep going past that, as we go across a little bit, we go down quite a bit. So now we're going to have some negative stuff, but it's still going to be very steep. So tan of pi on 2 is kind of like infinity. It's also kind of like negative infinity. So yeah, I think we'll start graphing now, and you'll kind of see it come together. So I'm going to make this one a bit taller. Let's say we have 4 there. That's going to be our x-axis. 1, 2, 3, 4, and a bit. And there we can put a bit. Okay. And we need to go up to 4 pi. So we'll bring it out over to here because I used some of our space for the unit circle there. It's not a big deal though. Get to there. Cool. Let's make this 4 pi halfway out there. 2 pi. And about here is pi. If you want to use a ruler to make these more precise, go for it. But I don't necessarily need you to when you're doing these questions. I don't think you need to. On an exam, you'll have graph paper probably anyway, so it's all good. We just want to understand what's happening here. Okay, now, remember I said interesting things tend to happen every quarter of the unit circle. So we've labeled around a pi, this angle of pi here, that's there. But something interesting happened here. We had an infinite undefined gradient here. So we want to mark in pi on 2 and also all these ones as well. So pi on 2, 2 pi on 2, 3 pi on 2. 2 pi on 2 is obviously pi. 4 pi on 2 or 2 pi. 5 pi on 2. I don't expect you to be as confident with labeling these yourself, by the way. So what I would do if I wasn't super confident yet, think about how this is pi on 2 to go to here. So that's there. And then we keep going again. We've got another pi on 2. So 1 pi on 2, 2 pi on 2. But 2 pi on 2 will cancel to just pi. That's why you have pi there. Go another pi on 2. Now we've gone 3. And that doesn't simplify, so we just go 3 pi on 2. Another one is 4. 4 pi on 2. And 4 divided by 2 is 2. So it's 2 pi. Go another one. Now we've gone 4 plus 1, which is 5. So we've gone 5 pi. And then 6, 7, 8, 9, 10. You just keep going around and just simplify them where you can. Okay? So that's how we can go pi on 2, 3 pi on 2, 5 pi on 2, 7 pi on 2. Awesome. Okay, so here, we start out with a gradient of 0 at 0. So we put 0 there. Now, next thing is we hit pi on 4. So pi on 4, and that's going to have a gradient of 1. So this is probably optional, but we could even just do it just to get our own head straight. We don't necessarily need to label it. Let's say this is 1 here. That means that by here, we're going to hit there. Now the rest of this, we have to go from here. Pi on 2 will get to infinity, okay? So basically, we have to get pretty steep from this point on. So here, it's hard to explain. I'm just gonna have to show you the graph. You kind of do just have to get used to the shape of it. Like you need to use a combination of logic and thinking about the unit circle with just getting used to the shape. And even here, we can't see as much as I wanted. So let's go on to Desmos so we can zoom in. So what I want you to focus on is, here's our 1. So let's put in pi on 4 and 1. Let's clean up the rest of these. That'll do. Okay. We'll change this to go up in steps of pi on 4. Nice. Okay. So when we come across to pi on 4, we're at 1. Well, what happened between there? Like, what's the shape of this? It doesn't go straight to it. I'm going to zoom in even more so we can see. And you can do this yourself on Desmos, so you can study it as well if you want. So we're just going to look at from 0 to pi on 4. And we only need to see from 0 to, I guess, 1. But we'll put a bit more than 1 so it doesn't look completely crazy. Okay, I'll zoom out a little bit. I'm going to plot a linear line as well, because I want you to compare it to a linear line. So this red line is a linear line, so straight, and see how it goes straight from 0 to 1. But our tan line goes a bit less than that, but it still ends up at the same point. And so it starts off like a little bit less steep, and then it starts getting more steep. Okay? Now after that, what happens after that? Does it keep getting more steep, or does it go less steep again? If it was going less steep, it would, around here, it would kind of turn around and start coming down again, but it actually gets steeper. Okay? So, point is, when we're graphing from 0 to pi on 4, and to get to this 1 here, you want to try and, it's not a crazy exaggerated, but you want to try and show that it kind of starts a little bit flatter and then comes up. Okay, so something like this. Again, it doesn't have to be perfect, but if you can put that little bend in at the start, that's nice. It's sort of like a parabola. So let's see if this works. Y equals x squared. See how it's a bit more exaggerated, but a parabola also starts off kind of shallow, and then it starts getting steep after. And we can probably make it closer to it. We did 1 over, maybe 2. 1.5 maybe? Hey. So see how the tan starts off kind of low and then gets steeper? And also the parabola kind of does the same kind of thing, okay? At least in this first section, they're kind of similar. So if you want to sketch tan super nicely, you should have that kind of curve there. Now, what happens at pi on 2? It's undefined. And so we can show that by putting a dotted line here at pi on 2. And it will come all the way down here. What happens next? Well, as we come across here, remember I said earlier, we've got a negative gradient now. because if we extend this line out so we can see it, as we go from left to right, we don't go up, the line goes down. So now we have a negative gradient. And is it still steep? Is this line here steep or not steep? Not steep would be like this. Okay, if I'm running along it, I'm not too scared of falling over. But if I'm running along the side of this looks like a mountain, if I'm running down like across this mountain, I'm terrified. I'm probably going really fast and I'm scared of falling over, right? So very steep gradient, very big gradient. And so it's a very big negative number. Okay, and now to give us some scale again, we can, to ourselves, you can mark it on there and say pi over 4. You just don't have to. So you can just mark it to yourself and say, okay, halfway we should be hitting 1. So we need to hit this point. And that's going to be -1 here. So we need to start really steep. And then when we get to here, we need to flatten out a bit and get to here and be flat-ish. Something like that. That's pretty good, actually. I'm impressed with myself, as always. So next we have, yeah, that goes like that. And to show you on the, well, I'll show you on this unit circle as well, so we can get used to just drawing it, because that's what we have in an exam if we want to think things through. We don't have the digital version. As we're here and we keep going through the angle, are we getting less steep or more steep? We're getting less steep. We're getting more comfortable with running down this hill, right? It's not going to be as terrifying. So we're getting to here, and then what is our gradient here? Gradient, we're completely flat. So our gradient should be 0, which is why we're back to 0 here when we're at pi. And we started here with a very big negative number, very steep negative, and then we're getting less steep, less negative. We hit here, this is our -1. I don't know if I said that, by the way. But it's similar to this first point over here, where it's going to be a gradient of -1, where we're going across and going down an equal amount. All right, so we hit there. Cool. Now after this, that one's getting correct. Okay, so we'll go back to the digital version for this. After that, so we just did this, right? From here up to infinite / undefined, negative big numbers coming down. There we go. And we just hit this. Now after this, yes, we keep increasing our angle here. Like we're past pi now. But look at this line. If you keep your eye on over here, it's doing the same behavior. So watch this red line here. Don't watch the orange, watch the red. It's having the same behavior as we followed at the start. Okay? And so it does the same thing as this. And because tan is just the gradient, we can just focus on what this whole red line is doing. Like the line that's created by this orange thing. We just need to focus on that whole red line. And because we're repeating our behavior, the graph's going to repeat as well. So keeping an eye on the red line, steeper, 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 we hit our gradient of 1, because as we go across from left to right, we go up an equal amount. As we keep going, we're getting steeper and steeper and steeper. We're going to hit that undefined infinity thing. And then we're going to get a negative, really big, really steep, and then come down, and we're going to repeat. And so the period of tan, as in when tan repeats, like finishes a full cycle and starts repeating itself, is actually pi. You start here, you come across, you get that big thing, then you come over here and you're back to 0. And then, yeah, the orange line keeps going, but the red line just repeats. And remember, we're just looking at the gradient of the red line. And so actually you repeat every pi. And coming across the desmos here, let's clean this up a bit. We probably don't need u anymore. We don't need u. We don't need u. Don't need u. Let's go back to a normal kind of scale. Look at this. We start at 0, we go up, we jump down, we go up to 0. And that was all in the space of a single pi. Then what happens? We go up, we jump down, we get back to 0. That was another pi. We go up, we jump down, we get back to 0, another pi. Here we go up, we go up, we jump down, we come back up to 0, pi. So we're repeating ourselves every pi. So really the hard work is kind of done once you finish this first pi here, because coming back to our book, well, actually, we'll just look at it here. As we go past pi, we're just having that increasing of gradient, getting to a possibly higher gradient, and then jumping down to a really big negative gradient and coming back up to 0. Okay, so looking at the book again, we just got to repeat what we just did. So here, at halfway, we're going to hit our 1. We're going to try and not just go straight to it. We'll try and put a little curve in. Something like that. Obviously, it's kind of small. It's hard to see anyway, but it's good if you can do that. 3 pi and 2, we can't quite hit, so we're going to shy away from it and go up. Okay, and now we need to put our asymptote line in, like that. And this doesn't have to be, like I probably keep saying a lot, it doesn't have to be perfect. You can even like hit the line a little bit. It's not a big deal. They're not super paranoid when they're marking it. Here, we're going to jump all the way down and make our way up. It's good to have a little reference point here. We're going to hit -1 halfway, just like we did over here. Okay, so that helps me to graph it. So starting here, start curving in like that. Try and curve it to there. That's probably the worst one I've done so far. And it's not a massive deal. You can kind of smooth it out. Because we're not actually marking based on this point, usually. I haven't seen people really mark that. You don't even need to hit this perfectly. So if you kind of screw that up, you can even just smooth it out and just go like that. Cool. And then again, now we're repeating ourselves again. We need to go up, jump down, and come back to 0. So here we need to go up, jump down, and come back to 0. And so let's put a little halfway going in. We're going to try and hit that. Go up, put an asymptote in, like that. Try and hit our -1 here. Come down. We'll come up from down. Go through that, hit there. And you probably start getting more relaxed with it now. You can even just do that. Starting from here, come up and go through there. Something like that. It's not an art test. Okay, so they're not crazy. What's the word? They're not crazy strict with the marking on this. Okay, you just need to show dotted lines here that are, you know, pretty straight. Again, you on an exam you'd be using graph paper, so that's even easier to do straight lines. You need to show these curves. Ideally, if you can put that little curve in there, like I showed you, it's nice. It's probably not 100% essential. And just show this wavy kind of shape, and hit the key points. Okay, and the key points come from drawing a unit circle and thinking about, all right, 0 gradient at this point. As we increase our angle, we're increasing our gradient. So we're going up, jump back down to negative, etc. So hit your key points, drawing the asymptotes. Remember, it repeats every pi. That's it. Tan's kind of tricky. I would practice a few tans yourself, and just be okay with being bad at it for a little while. You can see even there, I had to focus a lot on that, right? I've done these lots of times. So be okay with getting a few of them wrong, but eventually you'll get it to the point where it's good enough, or perhaps even great, right? But good enough is good enough because we don't mark super strictly on it, and so you might draw with your lines and be like 60% accurate, and that will get you full marks. Okay, doesn't need to be perfect as long as you're getting these key points. Notice how I was drawing quite lightly here. You can then come back and you should then come back and make it darker to show the parts that are important. That. Okay, so my final answer would be something like this. And if I made little points like this that I don't really want to keep, I mean, it's fine to keep this little line in here that we used to help us. Absolutely nothing wrong with that. And you can't really see these dots, and it's not really important anyway. But if you wanted to, you could come in and rub them out. All right, good stuff. That's the end of the question.